This is the seventh video on the recording. It's question 8 on your sheet. So the integral of the square root of 5 minus x times x minus 1 dx. Okay, so while the integral itself isn't terribly hard, when we get into it, getting the terms all in terms of u is the tricky bit here. So parts or substitution. I'm going to go with substitution here. Integrating by parts, perhaps, yeah, I haven't gotten into it. I'm going to let u equal the weirdest looking thing I can see, which is u is equal to the square root of 5 minus x. Okay, so just going to rewrite that before I differentiate it. 5 minus x all to the power of a half. Now, don't forget your chain rule. So I differentiate that. Du dx equals to a half times 5 minus x to the power of negative a half. Okay, minus means it should be underneath the line. So that is equal to 1 over 2 times 1 over 5 minus x to the power of a half, which is the square root of 5 minus x. And just rewriting that, du dx is equal to 1 over 2 times the square root of 5 minus x. So that doesn't quite resemble anything I have above here, so we're going to have to go a little further with it. Du is equal to 1 over 2 root 5 minus x dx. Now again, I have no 2's underneath the line. My square root of 5 minus x is not underneath the line, so I have to play with this more to be able to do my substitution. I'm going to bring my 2 times the square root of 5 minus x over. So this is a tricky integral, dx. Okay, now I want to be able to swap dx out now. I want to be able to swap out dx for what I have here, but I can't integrate du's when I have x's there, all right? But we know what the square root of 5 minus x is. The square root of 5 minus x, we called it u. So what I have on the right side here is 2u du, and that's equal to dx. And that's what I can swap part of my integral out for. So I have my square root of 5 minus x, which is u, and I have my dx, which I'm going to swap out for 2u du. Okay, I just have this middle piece here now. I can't put it in as x minus 1 because I have a du, so I don't want any x's, I only want u's. So I need to be able to express this in terms of u, and that's where the knack comes in here. So I've basically got an x minus 1. So let's start off with what we know. We have u equals the square root of 5 minus x. Now I need to get this guy. I need u's, I don't need x's, and I definitely don't need square root signs. So I'll square it. U squared is 5 minus x. Oopsie daisy, 5 minus x. Okay, now it's x minus 1. So I could reverse it a little to help it look a bit better. I could say minus u squared. So minus, I'd swap the signs on the other side, so I'd have x minus 5. Okay, I'm getting closer, but I don't want the minus 5 there, I want a minus 1. So to get from minus 5 to bring it up to minus 1, I'd have to add 4 to it, but I have to do it to both sides of an equation to keep it balanced. Add 4 to both sides of that, and what I end up with is minus u squared plus 4 equals, so x minus 5 plus 4 is x minus 1. So now I can swap out my x minus 1 for u squared, minus u squared plus 4. So I've got minus u squared plus 4. Okay, we start multiplying these out so to simplify it out a bit. U by minus u is going to give me minus u cubed. U by 4 is going to give me plus 4u. And then it still has to be multiplied by 2u du. Okay, we'll leave the old du on the outside, but we'll multiply in my 2. So I'll have the integral of minus 2u to the power of 4 plus 8u squared, and it's all du, okay? And du at the end. Alright, so that's an easy integral from here on in. So all I have to do is increase the power by 1 and divide by the new power. increase the power by 1, and divide by the new power. Okay, sorry, I'm finished my integral there now, so that's that. And now last thing to bring in is what my u is. And my u is the square root of 5 minus x. Okay, so I've got minus 2 times the square root of 5 minus x to the power of 5 all over 5 plus 8 times the square root of 5 minus x to the power of 3 over 3. Now look, you have a good integral there. It's plus c. That's absolutely fine. If we want to go a few steps further, that's okay as well. So remember, every time I square something, it gets rid of a square root. So if I have the square root of x and I square it, I get x. Okay? Now, if I square that, I'm multiplying it by itself, which is giving me x. So square root of x to the power of 4 is the square root of x squared by the square root of x squared. So it's x times x, which is x squared, basically. So what I end up with there is minus 2 times. So here I've got the square root of 5 minus x to the power of 5. So it's squaring again, but it's still got 1 left over. So it would be 5 minus x squared times root 5 minus x all over 5. And here I have a square root of 5 minus x. I can square it, but I have 1 left over. So it's 8 times 5 minus x, gets rid of the square root, times the square root of 5 minus x all over 3. Now look, we can go on and try and we can factorize out pieces of this. I can factorize out 5 minus x and the square root of 5 minus x. We can go for a common denominator of 15. I wouldn't be going to all these steps, I have to be honest with you. So minus 6 times 5 minus x to be squared times root of 5 minus x. Plus 5/8 is 40 times 5 minus x times the square root of 5 minus x. And then I'd be taking out a 5 minus x. Would I be taking out any more? I could probably take out the 6. I could probably take out a 2. So I could take out 2 times 5 minus x times the square root of 5 minus x all over 15 times 5 minus x times minus 3 times 5 minus x and plus 20. Yeah, then you can multiply in there if you want. But look, I think it's mad going to that level of simplification if you don't need to.